Hi friends, today we see about gears. Gears is a transmission device. With the aid of gear we can transmit the power from one place to another place. That's why we are using gear drives and gears. It's essentially this kind of gears used for transmitting more power. So the distance between very close or very low, that's there we are for this kind of gears to transmit power. So it have categorized into three categories based upon the shaft. The first one is parallel shaft, then intersecting shaft, non-intersecting and non-parallel shafts. First we discuss about parallel shafts. It have categories of spur gear and helical gear. Again, the helical gear is categorized into single helical gear, double helical or herringbone gears. Then the intersecting shaft, it may be categorized into bevel gear, counterflex bevel gear, zero bevel gear, then spiral bevel gear, meter gear, angular gear, then crown gear. So these are the type of gears comes under the intersecting shaft. Then next one is non-intersecting non-parallel shafts. It is crossed helical gear, then hypoid gear, then worm gear. So these are the diagrams shown. First we see about spur gear. The definition of spur gear: the tooth profile is parallel to the axis of rotation, transmits motion between parallel shafts. Then bevel gears. The definition of gear: teeth are formed on the conical surface used to transfer motion between non-parallel and intersecting shafts. Then helical gear, its definition is the teeth are inclined to the axis of rotation. The angle provides more gradual engagement of the teeth during meshing, transmits motion between parallel shafts. Then rack and pinion gears. The definition for rack and pinion gear is the rack and pinion combination converts rotary motion into the translatory motion or vice versa. It is used in lathe machine in which the rack transmits motion to the saddle. Then rack and pinion gears. The rack and pinion combination converts rotary. It's same. Then worm gears. The worm gear definition: it consists of a helical gear and a power screw, that is worm, used to transfer motion between non-parallel and non-intersecting shafts. Gear trains. A gear train is a two or more gear working together by meshing their teeth and turning each other in a system to generate power and speed. It reduces speed and increases torque. Electric motors are used with a gear system to reduce the speed and increase the torque. So this is the driver and driven gear. Driver gear is the primary gear where the power is resource power to be engaged in the driver power, from which it transfers the power or whatever we need that should be transferred to the driven gear. This driver is the primary one, then the driven is a follower one. So these are the terms used in gears. These are the representation. The terms used in gears. First one, pitch circle. It is an imaginary circle which by pure rolling action would give the same motion as the actual gear, that is the pitch circle. Then pitch circle diameter. It is the diameter of the pitch circle. The size of gear is usually specified by PCD, that is pitch circle diameter, or we can say pitch diameter. Pitch point. It's a common point of contact between two pitch circles. Pitch surfaces. It is the surface of the rolling discs which machine gears have replaced at the pitch circle. Pressure angle or angle of obliquity. It is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. The standard pressure angle are 14 and half to 14 half and 20 degree. Terms used in gears. Addendum. It is the radial distance of the tooth from pitch circle to the top of the tooth. Dedendum. It is the radial distance of the tooth from the pitch circle to the bottom of the tooth. Addendum circle. It is a circle drawn through the top of the teeth and is concentric with the pitch circle. Dedendum circle. It is a circle drawn through the bottom of the teeth. It is also called root circle. Circular pitch. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. It is usually denoted by PC. The circular pitch is equal to pi d by t. It is d is equal to diameter of pitch circle, then t number of teeth on the wheel. A little consideration will show that the two gears will mesh together correctly if the two wheels have same circular pitch. Note if D1 and D2 are the diameters of the two meshing gears having teeth T1 and T2 respectively, then for them to the mesh correctly, so PC is equal to pi D1 by T1 is equal to pi D2 T2. So D1 by D2 is equal to T1 by T2. Then diametrical pitch. It is the ratio of the number of teeth to the pitch circle diameter in millimeters. It's denoted by P suffix D. Diametral pitch P suffix D is equal to T by D. So pi by PC. So T number of teeth, then D pitch circle diameter. Then module. It is the ratio of the pitch circle diameter in millimeters to the number of teeth. It is usually denoted by M. Module M is equal to D by T. The recommended series of module in Indian standard are 1, 1.25, 1.5, 2, 2.5, 3, 4, 5, 6, 8, 10, 12, 16 and 20. The modules 1.125, 1.375, 1.75, 2.25, 2.75, 3.5, 4.5, 5.5, 7, 9, 11, 14 and 18 are of second choice. Then clearance. It is the radial distance from the top of the tooth to the bottom of the tooth in the machine gear. A circle passing through the top of the machine gear is known as clearance circle. Total depth. It is the radial distance between the addendum and the dedendum circle of the gear. It is equal to the sum of the addendum and dedendum.